Restoration Restoration Economic session. So I'm chairing this session. I'm Phoebe Stewart-Sinclair, that's me, and pre-COVID times. And I'm also giving the first talk, so that means that I can talk if I want. And then after that, Renee has got coming to us virtually. I think she has a pre-recorded session, but she will still be here if we need to ask questions or anything like that. And then Celia's going to talk. So hopefully one of you guys can time me because I'm not paying any attention to that. Okay, so I'm going to talk about a paper that we recently got accepted to be published in Conservation Biology. And it is one of my PhD thesis papers. It's called Spatial Cost-Benefit Analysis of Blue Restoration and Factors Driving Net Benefits Globally. So a bit of background on this. I just call marine coastal ecosystems blue ecosystems because it's faster. And these ecosystems are things like mangroves, coral reefs, seagrass, salt marsh, oyster reefs. And here we just focus on these top four because we didn't have enough data for oyster reefs. And they've undergone quite a lot of loss and degradation. And this has been the result of a range of threats. So climate change, overharvesting, pollution, yeah, you name it, it threatens them. But the issue is that they provide really valuable ecosystem services. So ecosystem services here are things like coastal protection, carbon sequestration, et cetera, et cetera. And when we have this loss and degradation, what that means is that we have issues with it regenerating itself, and then we have to do ecological restoration, which is why we're all here, right? So the issue is that blue restoration is pretty young field compared to terrestrial restoration. So it tends to be pretty small scale, expensive, and short term. So we really don't have much long-term monitoring or maintenance data, but it's practiced pretty widely around the globe, as you'll see. And that means that we need to have a look at the money, right? So the economic costs and benefits of blue restoration. So that's what I did. I'm not an economist, but economics, to be honest, is not that complicated. So I'm not going to do a methods talk. I did a really traditional cost-benefit analysis, and the first stage of this was to compile spatially explicit costs and benefits data for marine coastal restoration. And so to do that, I had two distinct databases. One looked at the cost of restoration projects around the world, and this was extracted from literature. This database was published in 2014, and I used the same methods, updated it to 2018. And then our estimates of value, so benefits of these ecosystem services, I extracted from this Ecosystem Services Value Database, which is compiled by the TEEB Foundation. There's about 1,300 estimates in there from like various habitats. So, well then, what we did was something called value transfer, which I'm not going to go into, but basically what you do is you pair the benefit values that you have from ecosystem services to your restoration projects. And to do that, I just wrote some code, found the closest point that was also from the same ecosystem, so mangroves, in the same country, and then I adjusted all the values so that they were in the same units, basically, okay? And I did do a little analysis to like put a spatial limit of 50 Ks on that, but there was no significant difference between that and no spatial limit, so I didn't set a spatial limit. Then the database looks something like this, where you have a location in latitude and longitude, you have the cost, the benefit, you can see the distance here in kilometers, so they usually weren't very far from each other. And then a whole bunch of other information, so what habitat it came from, what ecosystem services it provided, what techniques were used to restore that service, etc. And what we needed to do with the costs and benefits was to calculate a present value. So a cost-benefit analysis runs over a period of time, and you apply discount rates to these. So then what we did is we wanted to calculate the benefit to cost ratio. And basically you get your benefits, divide them by costs. If the number is more than 1, benefits are more than costs, great. If the number is less than 1, benefits are less than costs, bad, sad face, right? And so because there's a bit of discussion around different discount rates and ecological settings, and there's a bit of discussion around how long a habitat will take to reach its like pre-degradation condition. We made 9 models, so 3 different discount rates, 3 different time frames, and then we calculated the cost to benefit ratio for each of these models. Found no significant difference. So we chose one model, which is the middle model. So we use a declining discount rate of 3.5%, which is the standard UK number, over 60 years to keep going. So then we said to ourselves, okay, there's a real range of values in this data. So what are we going to do about that? So we did 2 scenarios. We have a baseline or optimistic scenario where basically you spend all your money up front and then you do very little maintenance and monitoring. You might have some citizen science, but basically you assume that your costs are outlaid in year 0 and your benefits are accrued every year over that 60-year time frame. And you also assume in this model that you're going to get 100% of the benefits, right? The same value that we had measured around the world. So that's pretty optimistic. Then we had a conservative or less optimistic scenario where you outlay your costs in year 0 to set up your restoration project. And then you assume that 5% of your initial outlay will go into maintenance and monitoring every year to year 60. And we also assumed in this scenario that you wouldn't have full benefits ever. And so we assumed that benefits would be about 75% of full benefits. And then we discounted them over time. And we also found there was no significant difference between these 2 models. So that's actually quite good because it makes me feel like our results are fairly robust. So we just continued with the baseline scenario, but we could just as easily have continued with the conservative scenario. And what we found, which is really exciting, is that in all of the ecosystems we looked at, the median benefit to cost ratio was more than 1. So in all of these ecosystems, coral reefs, so coral reefs is top left, mangroves top right, salt marsh top bottom left, and then seagrass bottom right. In all of them, the median value is higher benefits than costs. And even coral reefs, which is considered a really expensive ecosystem to restore, it's 4 times higher. Now, you can still see, because there's a really large range, that there's lots of red dots. So a red dot means in that project, the costs outweigh the benefits. So that's still really common in ecosystems like coral reefs and seagrass, bottom right. But in mangroves and salt marsh, you see a lot of green. And for the majority of the time, those projects are already cost effective or show net benefits. So then we asked, okay, how long before we get our money back? So the time to return on investment is obviously lowest in the ecosystems that have the highest net benefits. So you can see that in mangroves, the time to return on investment is only 18 years. And then it's just money in the bank after that. Whereas in seagrass and coral reefs, you can see that it's 70 years plus, right? So you start asking questions like, is restoration worth it over those timeframes with climate change issues in the mix, or do we just need to start streamlining our processes to get those costs down? And then we were saying to ourselves, okay, we could see here that there was a lot of variation spatially. So we asked if we had a look at the income of the nations that were doing the restoration, was there a significant difference in the benefits they were achieving? And the answer is yes for coral reefs and mangroves. So in coral reefs and mangroves, what we would classify by the UN as high income countries had low net benefits. It was less profitable. And in middle income countries, they had higher net benefits, significantly higher than high income countries. And I had no data on low income countries for these ecosystems. So that's a huge data gap because there's definitely restoration going on. And we hypothesized that these higher net benefits in middle income countries could be due to lower costs for things like labor, materials, that kind of thing, and also higher relative benefit to the local communities for things like fisheries, subsistence, that kind of thing. So then we said, okay, let's do a regression analysis, really drill down, see what factors might drive this. We had 6 different variables that we were looking at, and the underlying variables inherent to the projects. And what we found is that there was a significant relationship between restoration techniques and net benefits, which makes sense, right? If you have a cheap restoration technique, you're going to have higher benefits, and that's what we found. So in coral reefs, coral gardening and direct transplantation were associated with high benefits. Things like larval enhancement were associated with low benefits. Same thing in salt marsh, passive restoration had higher benefits overall compared to planting salt marsh directly, which is a bit more expensive. And they're doing it in the UK as well, so it costs a lot of money. Then we also found that there was a significant correlation between the kind of ecosystem services that are going to be provided by that habitat and your net benefit. So in mangroves, things like coastal protection and fish nursery services were associated with increased net benefits. So maybe that is something that you think about when you're planning a restoration project, like, okay, maybe I'll get higher net benefits if I put this in an open coast area, because I know that coastal protection gives me really high profits. And similarly, salt marsh was really important for water purification services, and it's a real priority in the UK at the moment because they want to increase water quality so that they can start setting up some shellfish aquaculture. So a lot of these things are really, these results are really common sense, but it's still good to see them after I've done a really complicated regression analysis that took me a couple months. And then the last thing that had an impact on net benefits was duration of the project. And this was exciting because there are very few long-term projects in blue restoration. And in seagrass, we found that if a project was longer than 2 or 3 years, it significantly increased the net benefits in those ecosystems. So hopefully I'm doing okay. Okay. So exciting conclusions for me is that overall, in all of these habitats, the median values were profitable, which makes me feel quite good because when I started my PhD, there was a lot of like tweets from people being like, marine restoration is a waste of time in corals and seagrass. But it can be profitable, so that's exciting. And thank you. And obviously, it makes sense that these longer, these habitats that we've been doing it for longer in, like mangroves and salt marshes, produce higher net benefits overall. That makes sense. But in this analysis, seagrass and coral reef restoration are still financially worthwhile. Okay, and obviously this is financially. There's other reasons that we might do it even if it costs money, right? So also more benefits in lower income countries, but I'd be really interested to see what's going on in what the UN classify as low income countries, because these are middle income. So those data gaps I'd really love to fill. And also technique and ecosystem service provided are really important, which we knew already. And there are heaps of limitations to this work. So for example, a lot of my ecosystem service values come from one ecosystem service benefit, right? So you get a value from mangroves and it's just the value of coastal protection. But that habitat also has cultural services, also has nursery services, etc. So these values are like really underestimating the true value. And the other thing is that we're going to make it be cheaper in future because we're people, right? So this is like worst case scenario, it's still profitable. But there's huge range. So some of these projects are still in the red. And I don't think it needs to be. I think we have the data available to like design projects in the future that are going to be profitable, produce jobs, and be successful. So for that, I would like to set you all homework. When this comes out, you should read it because restoration's cool and economics is all right. And other than that, I'd like to say thank you. And is there any questions? Do I have time? Yes, I have time for questions. Would anybody like to ask a question? Thank you. I don't have a mic for you. Okay, cool. Thank you.
I think economics is called a dismal science, actually. That's its reputation. My question is about that return on investment. You had an amazing range of years, if I'm remembering right, an 18-year payback up to 71?
Yes.
Okay, that's scary.
Well, it depends on your ecosystem.
I'm thinking in terms of scary, in terms of, say, that little thing called the Decade of UN Restoration.
Yeah, so that is like the median range. So in the high value for coral reefs, there's a lot of projects that are like the biggest scale coral reef projects are also the cheapest ones. So in those projects, like the lower range of that is like 20 years, right? Whereas the higher range is like 150. So yeah, the problem is that this data also comes from pilot studies where obviously they're very expensive and you're trying to think to yourself, okay, what if I did that over a hectare over 60 years, right? So I would say that even though that sounds bad, there's such conservative values that you can still, in 20 years.
So my question is,
yeah,
is there a role for self-assembling in these ecosystems to bring the price per hectare down?
Yeah. I mean, that's the goal. Yeah, so there's definitely, so the Coral Reef Consortium, for example, which is American, but they're having a meeting at the end of this year, and there's like 3 streams in that conference that are just about cost, right? They know it's expensive, and they know that they can do better. So yeah, I think that things are looking up. I just don't think that they're as dismal as they're painted to be, and this is a conservative assessment. So yeah, but you're right that it doesn't look good in those examples. Yeah, so far. Yep.
Hi, thanks, Phoebe. In looking at that cost data, did you see it coming down over time and see it coming down over scale?
Yes, so both of those things. It has decreased over time, but I wouldn't say it's significant. There's a trend, but like,
could that be worth rerunning? Because it's not so much has restoration cost in the past, it's more pertinent how much it costs now.
Yeah, so there's also debate as to whether or not you should even be applying a discount rate to something like carbon sequestration, right? Because the theory is that carbon sequestration now is worth more than in 60 years. But that's not true because climate change will be exacerbated and it will be worth more. But I have depreciated that value over time. And that is a failure of economics. But yeah, over time, like, so my values updated to 2018 are lower than the values in 2014. And when I looked at previous studies, like Costanza, they're lower than that as well. So I think that either that could be to do with having more case studies, so better data, or they're actually coming down over time. And they definitely go down over scale for sure, because nobody's going to be using the cost of a pilot study in a lab and then putting that out to 10 hectares, right? So, yeah. The answer is yes. Okay, I think we're out of time for me. Oh God. So next up, sorry, I don't have my, can you switch?